Hi, welcome back, and today we're going to look at dividing by a scalar and an unknown. So, kind of the most complex we can get for collecting like terms and simplifying algebraic expressions at this point. So, we're going to use the division law of indices to simplify our variables, and then we're just going to treat our numbers as normal division. So we can really kind of break this up into two things, and that's what I'll do for the first example. So here, let's write this in algebraic form to begin with. So that is 4x squared divided by 2x. So like I said, I'm going to break this up into 4 divided by 2 times by x squared divided by x. Because, right, we're just 4 times x squared, we can write it as 4 times x squared on the top, and 2 times x on the bottom, right? So we're just breaking it up into two different fractions. Because we know with fractions we can just multiply them as top by top and bottom by bottom. So I've just broken them up to kind of show what we can do. So here we get 4 divided by 2 is 2. Right? And then we have x squared divided by x. Well, that is just x. We just get 2x. So, next one we look at, 32 divided by 4, we get 8. And then we have x to the 2 minus 1, y. So we get 8xy. Whoops. Okay. And lastly, we have, I'm going to rewrite it properly as 64x cubed y squared divide, that looked terrible, 64x cubed y squared divided by 8. And notice how it's kind of nice if you line them up, the variables over top the other ones, because you can see what's going on and we can just almost work down. So that's, this time I'm going to actually work down. So 64 divided by 8 is 8. X squared and x1, and we get x squared, or x cubed and x1, we get x squared. And then y squared and y squared, those are just going to cancel out and we'll be left with 1. So in the end, we have 8x squared because we do not need to include that.